Greetings and welcome to Train Signal. You're watching Plan, Install, Configure, and Manage Client Access. It's a primary topic for the 70-341 Core Solutions with Exchange 2013 certification exam. The subtopic we'll be discussing in this lesson is Implement Load Balancing. Under the subject of implementing load balancing, this objective may include, but is not limited to, configure namespace load balancing, configure session initiation protocol or SIP load balancing, plan for differences between Layer 7 and Layer 4 load balancing methods, and configure Windows Network load balancing. Our scenario for this lesson is a company that handles event planning on a global level. They're called From A to Z Eventaganza. And yes, I just made that up. Now the problem they have is that they have high availability of their mailbox servers, but not of their client access servers. The goal here is to review options to provide solid load balancing and availability. Alright, so let's get started. Before moving forward, we have to look backwards at Exchange 2010. Now first of all, we need to make sure that everyone understands that load balancing is a method of managing traffic to distribute client connections to various endpoints so that no one endpoint takes the brunt of the load. Load balancing is also helpful for failover and high availability. Now, when we talk about the mailbox server role in Exchange, we can't load balance this server because the mailbox resides on only one server. So high availability is based off of active and passive solutions. So we have an active database and we have one or more passive databases in a database availability group. But when it comes to the client access server and we look at services like Outlook Web App and so forth, we can load balance these solutions. Alright, so we had the ability to load balance in 2010, but load balancing with 2010, it was a real pain and it was costly. With 2010, many of the client access server protocols required affinity, which is a relationship between the client and a specific client access server. So whether it was Outlook Web App or ECP, EWS, Outlook Anywhere, ActiveSync, the Exchange Address Book service, or Remote PowerShell, all of these benefited from affinity, that client to CAS connection. Now, you could use Windows Network Load Balancing or a hardware load balancer in order to handle Exchange with Exchange 2010. Layer 7 load balancers, also known as application level load balancers, were recommended. Now, distributing MAPI traffic across an RPC CAS array, this was painful, and the need for Layer 7 load balancers that included all of these awesome features like SSL offloading, service level monitoring, and so forth, this could be expensive. And that expense has to be considered in pairs because you need 2 load balancers per implementation if you wish to have redundancy of your load balancers too. So that's something that folks don't typically think about. It's great to have high availability of your mailbox servers. That's awesome. But then beyond that, to what extent do you have availability of your other services, of your network services, of your routers, of your cabling, of your method to access the internet? Do you have more than one type of connection? Are you using redundant solutions for internet access? So all of this, of course, is costly, and it takes time to design this properly. But depending on the amount of money you have to spend and the need to consistently be up and running, depending on the type of business you're dealing with, well, these are expenses that have to be considered. Now, you'll notice the mention of a CAS array here in looking back at Exchange 2010. In Exchange 2010, the CAS array was introduced. And basically it was a way to, through PowerShell, connect CAS servers together. After a client access array was configured for an Active Directory site, all client access servers in the site automatically became members of the array. But client access arrays are not required in Exchange 2013. And the reason for this is because the deployment of load balancers and the improvements to the client access server itself make them unnecessary. Alright, so we've looked backwards. Now let's take a look at improvements to Exchange 2013 client access. The CAS role has been altered to be stateless and act as a proxy with no rendering done on the client access server. So with Exchange 2013, client access servers are lightweight, stateless proxy servers, so there's no affinity needed, and we'll talk about that more in a moment. Basically, an Exchange 2013 CAS server authenticates a user and proxies the request back to the mailbox server, and that's where the user's mailbox resides and also where all of the rendering is done. All client interaction is now done through HTTPS with Outlook Anywhere. Even with internal clients, the Outlook Anywhere process, or RPC over HTTP, is the way that things are done between client and server. So MAPI or RPC client access, this is no longer used for client interaction. The CAS role is now the entry point also for unified messaging. Unified messaging connects by sending a SIP request to the call router, which is in the client access server. The call router answers the request and sends a SIP redirection to the caller, who can connect to the mailbox server through SIP and RTP directly. Although that's very similar to how the internet apps like Outlook Web App, Exchange ActiveSync, EAC, and Remote PowerShell communicate to the mailbox server. They go through the client access first, or through a load balancer to the client access server, and then the CAS server proxies them back to the mailbox server. So whether it's an HTTP connection with internet apps, or even if it's a POP, IMAP, or SMTP connection, it all connects back to the mailbox server in the same way. Now let's talk about this session affinity thing for a moment. According to the Exchange Team post by Ross Smith IV, a genius of a man if I've ever met one, here is how a connection is made with the CAS server from a protocol perspective. So a client resolves the namespace to a load-balanced virtual IP address. So that's the first part. That virtual IP address, or VIP, that is how the client connects to the load balancer. Now the load balancer assigns the session to a CAS member in the load balanced pool. So one of these CAS servers is going to get this session. They're not configured in an array, but they're part of the load balancing pool. The client access server will authenticate the request and will perform a service discovery by accessing Active Directory, and it will retrieve the following information. It will look for the mailbox version, which could be an Exchange 2013 mailbox, or in a state of coexistence, there may be Exchange 2010 or 2007 mailboxes. And then it will look for the mailbox location information. So it wants to know the database information, the external URL values, and so forth. Then the CAS server makes a decision on whether or not it's going to proxy that request, or it may need to redirect the request to another CAS server or another CAS infrastructure within the forest. Once the decision is made and it knows where the mailbox server is, then it proxies the request back to the mailbox server that is hosting the active copy of the database for that mailbox. Now, as far as the protocols used for all of this, it really depends on the protocol that's used to connect. So if the client is using an HTTP protocol, or HTTPS if it's secured using SSL using a certificate, then the protocol that's used between the CAS server and the mailbox server will be HTTP. If, however, the protocol used by the client is IMAP or POP, then the protocol used between the CAS server and the mailbox server will also be IMAP or POP. The post from the Exchange team mentions that there's a difference with telephony requests, because the CAS will redirect the request to the mailbox server that hosts the active copy of the user's mailbox database. And then what has to happen is, as we mentioned, the telephony devices, because they support redirection, they'll need to establish their SIP and RTP sessions directly with the components on that mailbox server. So at the end of this lesson, in additional research, you'll see the link that takes you back to the post from the Exchange team that discusses these enhancements in the client access server world, and it's written by Ross Smith IV. The cool thing about this is that, again, there's no need for session affinity. The client access server in this situation could drop out of the picture, maybe have some kind of power outage or failure, and things can switch over to the other client access server without the client being impacted, the end user that is, without them being concerned or worried or even knowing that there's an issue. There are some great improvements in the architecture of Exchange 2013 that make for a better load balancing high availability implementation. For example, the use of only one protocol in HTTPS. This is great because its failure states are well known and the response from clients is typically uniform. So this provides for a more stable solution. And in addition, there's a new method of handling HTTP cookies during forms-based authentication. So that's really important because it enables a logged-in user to resume a session on a different CAS server without having to worry about re-authentication. So the key to that is the new authentication method where rendering is handled on the mailbox side. Now for this to work, the servers have to share the same SSL certificate, and this way they're able to decrypt the authentication cookie that the client presents. So all of these improvements enhance the load balancing side to Exchange. There's also the new authentication method where rendering is handled on the mailbox side. So that means that if all client access servers have the same secure socket layer certificate, the session can go through either CAS. So we just saw a graphic of that as far as how the client access servers can take over for one another, and there's no longer a need for this affinity. But the key to that is to make sure all of your client access servers have the same SSL cert, and that's typically recommended anyway. So because of all of these different improvements, it's now possible to use Layer 4 load balancers in the mix. Now you can still use Layer 7, of course, and we'll see how there are benefits to using 7 over 4. But this is good to note that you can go with a cheaper hardware load balancer because of all of the changes in load balancing. So let's break it down a little bit in terms of CAS high availability and load balancing. For starters, to have higher availability or load balancing, you need more than one client access server. That's a given. To achieve both high availability and load balancing, you can use DNS round robin, although as we'll talk about in a moment, this is not really load balancing. You can use network load balancing. Windows Network Load Balancing is a free tool that's built right into your Windows server that you can utilize in order to provide for high availability and load balancing of your CAS. And then you can go with a hardware or a virtual load balancing solution. So let's start up at the top. Let's talk about DNS round robin. DNS round robin is not necessarily your best option, nor is it typically recommended over a hardware-based or virtual-based load balancer, or even Windows Network Load Balancing. The failover takes place at the client level as it reaches out for a DNS record for your client access servers, and it's provided one of the options that you have configured. Logically, you need multiple CAS servers to make this work, and you have to configure multiple A records for IP addresses of your CAS servers. But remember, there's no true load balancing or automatic failover with round robin. Now with Exchange 2010, DNS round robin wouldn't even work properly. And that's because of that affinity that we talked about. With Exchange 2013, it doesn't matter if the client reaches a different CAS server on each request, because the authentication is maintained. And so the session, it's in progress already, it will continue against the same back-end mailbox server. So that is really a nice aspect of this, so that if one of the servers does fail, then the client can use DNS round robin to select the next server to access. But again, as we mentioned, there's no real load balancing per se. You have different DNS servers that will hand out different IP addresses that are ordered in lists. And so certainly this is a more cost-effective solution. It's certainly cheaper than going with a hardware load balancer, but keep the limitations in mind. You might want to make that extra step and move forward and use Windows Network Load Balancing instead. Or perhaps use a combination of ideas. As far as Windows Network Load Balancing, NLB is built right into the Windows Server operating system, and it allows you to distribute the load between your client access servers. Basically, you assign a virtual IP along with the typical IP address for each member of the NLB cluster. Because the client uses the virtual IP to connect, if a client access server is unavailable, the network load balancer will connect the client to a different CAS. And again, because the authentication is still there, because there's no need for that affinity, the client will be none the wiser. So when a server failure occurs, the IP address will no longer respond, and therefore the load will be distributed between the servers that are still operating correctly. So this option provides server-based failover, because the client using that VIP will be connected to a different CAS server automatically. Now, this is a great solution if you can't afford a hardware-based load balancer, but you still want to put high availability in place. NLB is fine for labs and small environments where the expense of a hardware load balancer is an issue. But there are limitations. Let's talk about these limitations. For starters, NLB cannot be used with Exchange if the client access server is located on a mailbox server that's part of a DAG, because that mailbox server installs Windows clustering components, and NLB is not compatible with Windows clustering. So that's one negative. In addition, NLB doesn't detect service outages, only outages by IP. So it doesn't have service awareness. It's server aware. If the web service fails, the network load balancer has no concept of that, so it just continues to route requests to that server, and then the user has a broken experience. If the server's up, but the service is not working, the NLB doesn't understand that. So that may not necessarily be what you're looking for. You might need something a little smarter than that. You might want to know that even if the server's still working, which is great, if that service is down, and your end users are affected by that, well, then you're going to need something more than NLB in order to detect that service outage. And so as a result of some of these limitations, NLB can also result in port flooding, and it's not a good solution for small IP pools because it only does client affinity using the source IP. So it has a lot of little different issues like this. It has issues when it comes to scaling, so with anything over 8 nodes, it's typically not recommended that you use network load balancing. So imagine this scenario comes your way. You have to make a decision on load balancing. Cost is mentioned as a problem, but you want more than DNS round robin. So you're thinking Windows network load balancing. But then you're told in the scenario that the client access server and mailbox server are on the same systems, and the mailbox server is a member of a DAG. Well, now what? Well, you have two choices. You can either separate the two, separate your CAS and mailbox servers, the one that's part of a DAG, or establish a different CAS for the sake of the environment that you're going to load balance, or you have to go with a hardware load balancer. So that's good to remember for exam scenarios, for lab scenarios, as well as real-world scenarios. All right, let's talk about hardware-based or virtual load balancing. So this also uses a virtual IP, just like NLB, but it's much more sophisticated than network load balancing. Performance is better with a real load balancing solution. It's just true. Now we're looking at this, and obviously we're looking at two different hardware-based load balancing solutions. The one on the left is Kemp Technologies. The one on the right is F5. I've worked with both. A lot of folks like the features in F5. They're a bit more expensive in terms of the solution, but they offer a lot of different additional features as part of the appliance. Personally, I'm a huge fan of Kemp, and I love their load balancers. So depending on your personal choices and your personal leanings one way or the other, you can choose the load balancer that you like. One of the things I like about Kemp is that I have the ability to work with their virtual load balancer, which is really a virtual appliance. And so it's something that can run in Hyper-V or through VMware, and you can configure the settings just as if you're working with one of these physical boxes. That's great for lab environments, especially so that you get a feel for the interface, and then you'll be able to easily snap in a larger load balancer when necessary, and you'll already know the interface and the web-based console that Kemp provides. Now, that's an important aspect to load balancing discussions, especially from a training perspective, because we're not going to walk you through the configuration of either one of these appliances. Every appliance is a little different, in much the same way every router user interface is different. So to demonstrate one would really just be a waste of time. You typically choose the solution you want, and you can find step-by-step instructions for any vendor that you choose online. Now, the Kemp version is actually something that a lot of fellow MVPs have written about and use for their implementations, whether it's in demos or for articles that they've written. And so I find a lot of articles with the KEMP interface included. Let me just show you one that's listed at the end of this lesson as part of the additional research, because it will show you how following through the different screenshots through an article can be very helpful when you're new to load balancers and maybe you've never configured one before. This is the article I was talking about. It's entitled Introducing Load Balancing in Exchange Server 2013. This is part 2 of a 2-part series written by Steve Goodman. Now, this is listed in the additional research at the end of the lesson, so I recommend that you take a look at both part 1 and part 2 on msexchange.org. What's cool about this second one, though, is that here he goes through some really cool information about the way load balancers work, and you can see here the virtual IP that the client connects up to, and that brings it into the high availability pair. And then you see you have your CAS servers, and then you see you have your mailbox server infrastructure, which is most likely part of a DAG. Now in this case, he maps this out for you, and then he uses the KEMP LoadMaster solution and really walks you through creating the initial VIP. He walks you through configuring the VIP to use layer 4 load balancing, and that's what we're going to talk about next actually, is layer 4 versus layer 7 load balancing. He goes through all of the configuration, and you can see here even on the Exchange server side, he goes through the configuration of the HTTPS namespaces in the EAC, applying the namespace to all web servers, and then of course configuring the Outlook Anywhere internal and external URL for the system. So then he also goes through and discusses per service load balancing, which is a little bit different, and you gain the benefits with per service in layer 4 load balancing without having to go to a layer 7 load balancer. So there are some benefits to this, but it's a lot more complicated to configure, and again we'll talk about this in a moment. But it's a great article, really worth taking a look at because you can see the interface. But as I said, every load balancer is going to utilize a different web-based console or user interface. So with each one, you'll have to become familiar and comfortable with that interface. But no doubt, the vendor that you choose will have step-by-step instructions on how to configure all of this. So you don't have to become an expert in load balancers in order to get this done in your environment. You simply have to know the basics that we're talking about here in order to understand what it is you're looking to actually accomplish and then what the load balancing solution can do. So whether or not you want Windows Network load balancing or a layer 4 hardware load balancer or a layer 7 hardware load balancer and so forth. Alright, let's jump back over to our slides and let's talk about this difference between layer 4 and layer 7. As we mentioned a bit earlier, the new architectural changes with regard to the client access server makes it so that you don't need all the expensive layer 7 intelligence, and a layer 4 load balancer is typically all you need. You can still decide to go with a layer 7, and we'll talk about why you might do that. However, layer 4 load balancers in a basic form can also determine if a server is in a failure state or check for specific services like Outlook Web App and ensure that it's up and running. So oftentimes that's really all we want from a load balancer. We want it to understand when a server is in some sort of trouble, some sort of failure state, and then react accordingly. However, layer 4 load balancers cannot determine amongst multiple services if a single service is down and then reroute just that service. So that requires layer 7. So we have choices in this regard when it comes to the utilization of a layer 4 load balancer. We can assume that if our most important service is up, let's say Outlook Web App, then we can classify that CAS server as available. Or we can actually configure multiple VIPs tied to different names, one for each service. So with a layer 4 server, it's a little bit more complicated to do that, and it basically means we need an IP address assigned to each service, like OA or EWS. So let's look at this visually for a moment. If we take a look here, we're looking at a layer 4 and a layer 7 setup with single namespace. So if you're using load balancers with either layer 4 or layer 7, you can go with a single namespace implementation. Now, if you're using layer 4, the most basic and most restricted, but the easiest method for hardware load balancing, and the more cost-effective one depending on the type of load balancer you're using. The setup is basically a single namespace that will load balance all of the traffic for all of the different protocols. And you can see OA, ECP, Outlook Anywhere, EWS, and you can see that it can handle the balancing on the back end for the client access servers. Now, as we mentioned, it doesn't have the ability to reroute traffic from one CAS server over to another in the event the service is down. It doesn't work that way. So Layer 7 load balancing offers some additional functionalities. With Layer 7, it has the ability to really look inside the traffic and understand what's coming through, and then take appropriate actions based on the type of traffic or the destination for the traffic. So based upon the type of workload, the traffic can be sent to a different server. Alright, so in terms of namespaces, you can use Layer 4 and Layer 7 with a single namespace. The value of going with Layer 7 is that it's smarter and has the ability to adjust the workload to a different CAS server should the service be down on one CAS server, or should you have configured rules to simply route the traffic a different way. If you wanted to provide for this same type of functionality using Layer 4, you can get some of that functionality with Layer 4 by utilizing multiple namespaces. So here you can see with Layer 4 with multiple namespaces, this is a lot more work, but you can establish different namespaces for each of your services, and then of course with each workload it now has its own virtual service, and then as a result you can get a per workload or per protocol availability. So just like Layer 7 then, the failure of any single workload on a server doesn't necessarily have an impact on other workloads. The downside of course is that it's a lot of configuration and you have to utilize a bunch of different external IP addresses and configure all the different namespaces and so forth. Some may say, well, there's also an extra expense when it comes to the certificate that you need to purchase here, but really when you think about the load balancer you're purchasing, that might even be cheaper than the L7 load balancer that you might need to purchase if you wanted to accomplish this same thing within a single namespace. Others may not necessarily like the idea and complain that you're exposing the end users to a variety of different IPs and URLs, but in all honesty, the only URL that an end user would be exposed to here would be the Outlook web app URL. All the others are configured automatically through AutoDiscover. So again, this comes down to expense, the amount of time you want to spend configuring your solutions. If you have the money for a Layer 7, then you can certainly go with that and you can make it all happen with one namespace. The configuration is much easier, the certificate side is more cost effective as well, and it's a lot better solution because you have a lot more intelligence involved. But working with Layer 7 load balancing is a little bit more complex. Layer 4 is certainly the more simplistic solution. So there you have it. There is no perfect answer to the question of which type of load balancer solution you should go with. It comes down to your needs, how basic you need it to be, how cost effective you need it to be, and what you're really looking for out of load balancing. Do you want your services load balanced in this way, or do you prefer to just be concerned about making sure the server itself is load balanced and made highly available? Let's talk for a moment about namespaces and site resiliency. We just talked about namespaces, but we talked about it simplistically in terms of accessing your CAS servers through a virtual IP through a namespace that connects to your load balancer to the CAS servers. But there are additional namespaces that always have to be taken into consideration for your CAS servers, your load balance servers, for your entire environment, maybe even for sites. And so when you're dealing with multiple sites, you need redundancy of these namespaces as well. So the namespace model within Exchange 2013 has been simplified, and this benefits us when it comes to load balancing with regard to the number of namespaces that are needed in order to make this happen for site resiliency. So here's what we needed with Exchange 2010. We needed a primary and secondary data center internet protocol namespace, so we needed 2 there. Primary and secondary data center Outlook web app failback namespaces, so 2 more namespaces there. Primary and secondary data center RPC client access namespaces, So we had two more. Auto Discover namespace, there's one. Legacy namespace, there's another. So that's 8 namespaces so far. And then an optional transport namespace, depending on whether or not you are doing ad hoc or partner-to-partner encryption. So there's a 9th one. Now with Exchange 2013, there are still a lot of namespaces needed in a site-resilient design, but 2 are no longer needed, those RPC client access namespaces. So that's just something to keep in mind, that this is another adjustment with Exchange 2013 because they are no longer using the RPC client access side to the connections with your CAS servers. Because that's gone, you no longer need those namespaces. Now you might be saying, well, it's still a lot of namespaces to be concerned about. Yes, it's true, but it's 2 less. And so it's good for you to know that. All right, we've covered a lot with Eventaganza. After reviewing all of the options, it appears that they've decided to go with 2 Kemp load balancers using Layer 7 for the added functionalities over Layer 4. They'll make sure all of their CAS servers use the same SSL certificate. They're also looking at providing site resilience in the future, and they appreciate that fewer namespaces will need to be considered. Alright, so for additional research for this lesson, we have the Exchange 2013 Client Access Server Role. That's an article from the Exchange Team blog by Ross Smith IV. Then we have load balancing from TechNet. And then we have the 2 introducing load balancing in Exchange 2013 with Steve Goodman. We have part 1 and part 2. So we hope you found this informative. Thanks for watching, and I'll see you in the next lesson.